Okay, guys, so here is our introduction to transformations. And you probably got an introduction to this when we were in class. So this is just to kind of add a couple things and then give you a place to kind of reference if you have any questions. So we have four basic, what we call parent functions, which are just an equation without any changes made to it. And those four equations are y equals x squared, y equals the square root of x, y equals the cube root of x, and y equals the absolute value of x. And each of those have what we call kind of like a formula for making transformations to them. So ways to move your graph up, down, left, right, to flip it, or to make it narrower or wider. Okay, and we're going to talk about what those are. So the general formulas that we have are what you really need to remember for this learning target. The first one is A times x minus h squared plus k. The second one, a times the square root of x minus h plus k. The third one, y equals a times the cube root of x minus h plus k. And then our last one, you can probably guess how this is going to go, a times the absolute value of x minus h plus k. Now, we have three different values for our formulas. We have A, which represents the width of your graph, also known as a vertical stretch or compression. Okay, a vertical stretch or compression. H is left and right. Okay, left and right. Horizontal. And then K is up and down, and that's our vertical. Okay, so a couple things that I want to point out about this. And we talked about this in class, and you guys would have seen it in the activity that we did. Because the inside of all of these is minus h, the left and right is always going to be the opposite of what you think. Okay, so we're going to put the word opposite here. And what that means is when we're moving left, it's actually going to be a positive. And when we're moving right, it's actually going to be a negative. Up and down work the same way. Up is positive, down is negative. Okay. Your width, and I'm going to, maybe I'll just put it up here. Your A value, okay. The A value has two different things. If your A value is greater than 1, it's what we call a vertical stretch. Okay, so that means it's a very narrow graph. If A is greater than 0, but less than 1, okay, so A is between 0 and 1, it's what we call a vertical compression. And that looks like a very wide graph. Okay, that makes our graph look, and it seems kind of like the opposite is what it should be. But a stretch, this is kind of the way I describe it. A stretch is like this. So you're taking your graph and you're stretching it, which actually makes it more narrow. So you're taking this graph and you're stretching it like this, so it makes it more narrow. If it's a compression, I'm taking my graph and I'm squishing it down, which pushes it out to the side. Okay, so we'll take a look at a couple of these. All right. So for something that has an A value of 3, and we have x minus 4 squared plus 5. If I were to describe what that means that I have a vertical stretch because of this. I'm moving right 4 and I'm moving up 5. Okay, so that's what this is from. Okay, so that's that whole equation. Now, the other thing I want to point out about your A value is that if I end up with a negative value, okay, so let's say it comes out to be like this. If I end up with a negative value, I'm going to show you what that looks like on the calculator. So I type in negative 2x plus 3 squared minus 4. So if you look at your graph, this is what it's actually going to look like. You will notice that it moved my graph left 3. Okay, that's that positive 3. Down 4. Okay, that's my minus 4. And then negative in front actually flipped my graph upside down. So that's what a negative value does. Okay, so you've got your left, right, up, down. Your A value tells you how narrow your graph is going to be or how wide it's going to be. And then if it's negative, it's going to flip it. So let's do one more with the different width of your graph. So if I do y equals 3x squared. Okay, so I'm going to show you just the parent function first, which is just x squared. Okay, so that's your standard graph, no changes. If I also graph 3x squared, let's see what happens. Notice how it makes it more narrow. Okay, now if I change this to 0.5x squared, I'm going to keep the parent one. So I have my original. Now 0.5x squared comes out to be much wider. Okay, so those are how the different values affect your graph.
Point to the ones that are circled.